Hi everyone, welcome to Java Techie. In this tutorial, we'll learn about how to use Avro schema to produce and consume messages using Spring Boot. Additionally, we'll explore the concept of schema registry, what does it mean and what benefits does it provide. Okay, alright. Let's assume I have a stable Kafka producer and consumer application where I'm sending employee details to a Kafka topic and the consumer read it from the Kafka topic and perform some further operation. This is a happy scenario of pub/sub mechanism, right? But what if I change the producer data? If I change the record to this new format where I'm adding a new field called middle name and I'm renaming one existing field called email ID and I'm removing one field called DOB. Now the problem starts from here. Will my consumer work with these new records? The answer is no, because the consumer is not aware of data changes, and that's a big problem, isn't it? If there is any changes in my data, it will directly impact all my consumer, which is not acceptable in real-time implementation. So how to overcome this? The simple solution is to write a new producer and consumer application so that new data will be produced and consumed by the new instance without impacting the existing flow. However, that requires too much work and that is not a feasible solution. Then again, how to solve this problem or how to handle data changes or schema evaluation. So that's where Confluent Kafka introduced the concept of Avro schema, and to store those schema it has a component called Schema Registry. Okay, now let's go one step ahead and understand what this Avro schema is, how to use it and how to handle schema evaluation. Then further we'll understand how it works internally. So when I am saying Avro schema, it's nothing but a contract between your producer and consumer. It represents the data that you are going to serialize while producing and deserialize while consuming. Now if I try to represent the equivalent Avro schema of our record, it will look something like this. Now if you observe carefully, we are defining in Avro schema saying that okay, these are my fields which the producer will send and the consumer will consume. In case the producer is not sending any of the field or adding any of the new field, then there should not be any impact on the consumer side. Also, if any changes are made to the schema, it will be considered as a new version. Okay, that is what called schema evolution. I have the contract or schema with me. Now how can I use it? That's pretty simple. Once you prepare the schema, you need to generate the corresponding object out from the schema. So you need to define all the field, whether it is optional or mandatory, in your schema file. Then you need to generate the Avro object. To convert Avro schema to Avro object, you have multiple options. You can directly use the Avro tool, or you can use Maven or Gradle plugins to generate the object for you. Once you have generated the Avro class, then going forward you can use this employee.java as a data object which you can produce and consume. But while producing this object, we need a serializer from the producer end who will serialize the Avro encoded message and send them back to the Kafka topic. So we can use Kafka Avro serializer. Similarly, we need a deserializer from the consumer end who will deserialize Avro encoded message and convert them back to the object. So we can use Kafka Avro deserializer. That's straightforward, right? Here Kafka Avro serializer and deserializer takes all the responsibility of converting your encoded Avro message to the corresponding object and perform the serialize and deserialize operation. That's interesting. But where is the validation part? The encoded Avro message that my producer is sending, whether it matches to the schema I have defined or not, where are we validating it? Or how does my deserializer deserialize the raw bytes to an object without knowing the schema? That's the major part we need to deal with to avoid failure on schema evaluation, right? So that's where schema registry comes into the picture. What schema registry does, it store your schema. So when Avro serializer serialize the record, it first validate and store the schema into the registry. Then when Avro deserializer deserialize, it first takes the schema from the registry, validate it with the messages and then deserialize it back to an object. The primary purpose of schema registry is to provide a way to store, retrieve and evolve the schema in a consistent manner. So in the future, if I'm making any changes to my existing schema, it will create a new version and store it into the schema registry. Since schema registry has the flexibility to support both backward and forward compatibility, if any upgrade happens to the schema, it will support the old schema as well as the new schema. That is how it handle schema evolution. Hope this makes sense to you. No worries. We'll do a hands-on example with all the theories we understand. Okay. So without any further delay, let's get started. So let's create a new project to demonstrate this schema registry. I'll create a new project, then define all the required field, click next, then just define all required dependency. I'll add web dependency, then I need Lombok dependency, then I need Kafka dependency. Click next. Now once it imported, just go to the pom.xml and we'll validate that we have added the web dependency and we added Spring Kafka and we added the Lombok dependency, right? And anything else? No. But why there is error? Okay, it is saying starter parent 3.2.2 not found. Okay, let's downgrade it to the 3.2.1. Let me update the project. Now let me clear this. Next, we need to set up our Kafka environment. So we want to use the Confluent Kafka. You can download the binary distribution and you can start the Zookeeper, Kafka server, service registry, everything from the command prompt. But I would prefer here to use the Docker Compose file. I will just define all the container I need so that if I will do the Docker Compose of, it will start all the services for me. Okay, so I will just define the Docker Compose file in this root directory. Then I can define all the services I need. So if you observe here, let me zoom this for you. I need the Zookeeper, then I need the broker, which is nothing the Kafka server, and then I need the Kafka tools. So this Kafka tools is available for administrative tasks, so you can ignore it, this is optional. And I need the schema registry. So you understand what is the role of schema registry, right? So we need this schema registry component who will store the schema and validate with the encoded Avro message. And we need the control center. So this is just a UI platform to monitor your Kafka activity. Okay, so this control center depends on Zookeeper, broker and schema registry. It collect all the information from these three components and mapped into the UI. Okay, and it will run on the port 9021 and these are the environment variable of each services what I have defined. Okay, no worries, I will share this GitHub code in the video description. You guys can refer to the same file. So now to start these services, we need to start our Docker first, right? So I will just open my Docker desktop in my local machine, and once it will be start, then I can just trigger Docker Compose up so that all the services what I have defined in this compose file will be up and running for me, and I can do the further step with this Confluent Kafka. So let's wait it to start. So Docker is up and running now. Now what I'll do, I'll go to the terminal. So simply I will trigger Docker Compose -d. Okay, now if you observe, it is just starting my all the services. So if you observe, it started the Zookeeper, Kafka tools, then Kafka server, schema registry and control center. So to verify that whether it started or not, what I will do, I will just check the port of my control center, that is 9021. I will go to the browser and I will trigger 9021. It's loading, right? So it means it started. So we are good here. Now what you need to do, we'll follow the same step what we have discussed here. First we'll create the schema, then using the Maven plugin we'll generate the corresponding Avro class, then we'll define the producer and consumer, and we have defined the serializer and deserializer and schema registry. Okay, so the first step, let's create the schema. So just go back to id. In the resource I will create a folder called Avro. Then I need to define the schema here. Okay, so let me create a file called employee.avsc. So this .avsc is the extension of Avro schema. Just create it. Then here you need to define what is the package where you want to keep your generated class. So just define the package name. I'll define com.jabatechie.dto. Let me zoom this for you. Fine. Then next you need to define what is the type. So you want to define the Avro record, right? So I'll define the type as a record. Now what is the class name you want to keep? So from the schema, the class what it will generate, what name you want to give. Okay, so the name I'll define employee. Next to that you need to define all the field which you want to produce and consume. So what you can do, you can define fields that need to be one array, and you can define all the field you need. So if you will verify the field we have defined, id, first name, last name, email and dob. So let's go to the id. I'll define the field name is, the first field name is id, of type it will be string. Okay, simple, right? Now I will define another field. Let me copy the same. The field name is first name. Okay, and okay, there is a spelling mistake. rst name, of type string. Then the next, last name, type is string. Then what else? First name, last name, email and date of birth, right? So define the email here, of type string. Then dob, of type string. And also let me add one additional field called age, of type int. Okay, you can define any data type here, string, int, double, as per your requirement. Okay, also you want to keep, let's say I just want this email to be optional. So what I can do, I can define here default value should be, you can define null or you can define empty. Okay, so this is what the schema I have defined. This particular field my producer will publish and my consumer will consume it. That's fine. Now next, if you observe the flow, we have the Avro schema with us. Next we need to generate the Avro object by using the Maven plugin. Okay, so let's go to the id and we'll add all the required dependency and plugin. So just go to the pom.xml and then I will add all the required dependency. So if you observe here, we need the Avro serializer. Let me zoom this for you. And then we need the schema registry and we need this Avro object. Okay, then we just need to add the plugin. Just add it here, just update it. So we are getting the error, what it is saying, cannot resolve this dependency. Okay, so it is looking from the Maven central repo to load these two dependency, schema registry and Avro serializer, but in Maven it is not available. Okay, so what I'll do, I will tell in the pom to load it from the Confluent repository. Okay, now if I'll just update it, there should not be any error. Okay, there is no error. Now if you will go to the plugin section, if you observe here in the configuration, I am telling here this is what my source directory, where you can find my schema, and this is what the output directory where I want you to generate the object for me. Okay, and the version of Avro Maven plugin we are using 1.8.2. So that's fine. Now let's run the Maven goal to generate the object for us. Just go to the Maven, run the install. So here simply we are telling to take the Avro schema and generate the Avro object for us. So the build is succeed. Now to validate that, what we can do, go to the main Java. Now you can see here, right, there is a package called DTO, and this is what the package name we have defined in our schema. Can you see here? The namespace or the package we want to generate the Avro object is this. Now if I'll open this, I can see the Avro class. Now if I'll open the employee.class, let me zoom this for you. This class extends from specific record base, specific record, and this is what the schema what we have defined. Fine. Now if you will scroll down, you will find all the field. Can you see here? ID, first name, last name, email, and date of birth and age. Also you can find the constructor here. This is what the default constructor, and you can find the getter and setter method as well. I mean, this is just a class generated by the Avro. Now we can use this particular employee as a data object to perform the producer. I mean, we can publish this particular object and we can consume this particular object. So to do that, let's create one producer and consumer application. Okay, so what I'll do, I'll create a separate package here itself, and I'll create another for consumer. So I'll just define package. Fine. So let's create one producer and consumer class. But before that, let's verify the flow what we have discussed. We have the schema with us, and we created the employee.java class, which is nothing the Avro record. Now we'll create the producer and consumer. Then we'll define the Avro serializer and deserializer, and we'll validate the schema registry. I mean, we also need to give the configuration of schema registry to store all the schema. Okay. So we are in the third step to create the producer and consumer. So just go to the idea, and then I'll just create a class here. Then just annotate here @service. Then I just need to define the Kafka template, right? Private Kafka template of type, you can define string, and of object employee, right? That is what our object, Avro object. So I can define template, just do the auto add. Then just define the method public void send, something like that. Okay, define the object what you want to send, employee. This employee is not our object, right? It's the Avro object. I mean, you can consider it as a Avro record. So to do that, I will just do Kafka template dot send. What is the topic name? We have not defined the topic, and we want this topic to be auto create. So for that, what I'll do, I'll just create a config class, or I'll just create a package called config. Then I'll define class name Kafka config. So I just need to annotate this with @configuration. Then I'll just create the topic. I just need to create the bean of topic. Public new topic. This is the class name. Okay. Now create topic. I'll just define the method name. Then return. See, if you observe here, you just need to define the name of your topic, number of partition, and replication factor. So I'll just define the name, let's say Java Techie -Avro, and number of partition I want 3, and replication factor I want 1. So I can define 1. Just need to typecast to sort. Just annotate this @bean. Let me maximize this. Yeah, define @bean. Now I don't want to hardcode this topic name here. So what I want to do, I have the application.properties file, or I will just create a file called YML file, and here I can define my topic name. Okay, so I'll define topic name equal to this. So I want to make it generic, so I have defined the topic name in my configuration, I mean the YML configuration, and that I will load in my config. So you know how to load the value from the properties file, right? I'll just define private string topic name. I just need to annotate here @value, and I just need to get that value from my YML file. So just define the dollar and give the key. What is the key name? Topic dot name. That's it, right? So I no need to hard code here. I can use the topic name. Same topic name I can use while producing the messages. So here also I can use the topic from the properties file. So let me copy this syntax. I need this topic to publish the messages, and what data you want to publish? Employee. Fine. Next I'll just capture the return statement so that we can just add the log statement, what data we are sending, what is the offset count and everything. Okay, so this will give you the future object. Can you see here? This will return the completable future. Now I'll take that future object and I'll just get the result. Okay, so this will be employee. Nothing, I'm just checking if there is no exception. Print that okay, message has been sent to this is what the message we have sent, and this is what the offset count. But if there is a error, just print that unable to send the messages. Okay, that is the simple things we have done here. Now let me define the consumer. Let me copy the name. I'll go to the consumer package, create a new class. Fine, consumer is the simple one. What you need to do, just define the annotation first to make it a component. Define service, then you just need to write a method to listen to the topic. So just define public void read messages. Which type of messages it will read? Let's say define consumer record of type key as a string, value as a employee. Fine. Now I just need to tell to this consumer from where he need to read that messages. Okay, so just annotate Kafka listener and just define what is the topics. Just tell that okay, read it from the topic what I have defined in my properties file. That is the reason I move it to the properties file to make it generic rather than hard code in each and every place. I have just defined it in a single place. Okay, so topic dot name. So we are telling to this particular listener to read the messages from topic what I have defined, and what messages it will read of type employee. So what we can do, just add the log statement. Okay, to verify that SL4J. This we added from the Lombok. Now here I will simply first get the key. Are we sending any key? No, we are not sending any key, right? But still let's capture it, or we can pass it from the producer itself. Consumer record dot get key. What is the value we are sending? Consumer record dot value. So now we can just add a log statement. Just add the log statement. Avro message received for the key is this and value is employee, right? Okay, I have done the mistake. This value should be of type employee. That is what we have defined. So this need to be employee, because this is what the value we are getting, right? Key is a string. It can be serialized and deserialized by a string serializer or deserializer, but value is something object which is Avro object, and it needs to be serialized and deserialized by the Avro serializer and deserializer. So that we are going to define in a moment. So this is what we are getting. Fine, we have defined the producer and we have defined the consumer. Now let me define a controller so that I can trigger an event. So just create another class. Just define the package called controller. Just annotate here @rest controller. Then you can define you need to inject the producer. Then just define an endpoint to trigger the event to the Kafka topic. Okay, so I'll just define public string what type of messages we want to send, employee. Then you can simply define your producer dot send what is that? Employee object. And I can return some dummy string message, and this need to be annotated at the rate request body, and I need to annotate here at the rate post mapping since I have the request body, and I'll define the endpoint events. And this particular application I want to run it in a different port, so I'll just define server dot port, let's say 9292, or let's take some different number, okay, 8181, something like that. We are good now. Okay, so if you cross verify the flow, we have created the producer and consumer, and now the next step, we need to define what is the serializer of my value, what is the deserializer of my value, and then where is my bootstrap server is up and running. Everything I need to define as a configuration. So what I can do, I will prefer to define in a application.yml file. You can also create a Java based config class, but I can define here in the YML file. That is the easy approach. Okay, because I don't want more customization, so I just need to use the producer and consumer config in the YML file. But if you need more configuration, I mean customization of more configuration, you need to go with the Java based config approach. So I need to define here Spring Kafka producer first. Okay, in the producer first I need to define where is my bootstrap server, I mean where is my Kafka is running. So where exactly it is running, you can define localhost 9092, right? That is what usually we define, localhost 9092. So if you observe your docker compose file, go to the docker compose file, the bootstrap server, if you'll scroll, yeah, can you see here, this is what your Kafka server, right, broker, and it is running on port 9092. That is what we are just defining here. So just go to the YAML file 9092, but we are not running it in our local, we are running it in a docker. So you need to give the default IP. So my default IP is 127.0.0.1 colon 9092. Fine. Now I can define the serializer, key serializer. Okay, so the key serializer is the plain string. I can use this string serializer, which is the default given by the Kafka itself. Okay, but if I'll define the value serializer, I cannot define the JSON deserializer here. I need to define the Avro Kafka Avro serializer. Okay, coming from the Confluent. That is what we have discussed in our flow, right? We need the Kafka Avro serializer to serialize my value to the topic. So we need to define that. So just define the class io.confluent.kafka serializers. Can you see the class name? Kafka Avro serializer. We are using this Avro serializer to take the encoded Avro messages and send it to the Kafka topic. So we are good. Now also we need to define the schema registry, right? So I will just define properties schema registry. Now here is your schema registry is up and running. If you go to your docker compose file, the registry is running on port 8081, right? So I need to define that HTTP, then your IP and your port, that is 8081, and my IP is this one. Fine, this is where my schema registry is up and running. We are good. Now let's define the consumer configuration. Now consumer also you need to define the bootstrap server. This is what the bootstrap server. Let me copy this. Next, here also if you observe in the consumer part, we need to define deserializer properties, right? So I can define here key deserializer is the same, that is my string, So I am using the default Kafka string deserializer, but value deserializer should be from IO Confluent Kafka Avro deserializer. Just define that class. We are good here. Now next you need to define auto offset reset. You can define it as earliest or latest, it is up to you. Next, in consumer also you need to tell to that consumer, okay, where is your schema registry up and running. If you observe the flow, both Avro serializer and Avro deserializer is connecting to the schema registry, right? So you need to give information about schema registry to both your consumer and producer. So we have given here in the producer. Now same, let's give in the consumer. So it need to be inside the code. So that's fine. I'll just define properties. Next, just define one additional field, that is to tell to the consumer to read the Avro messages. Okay, so there is something called specific, okay, and Avro reader equal to true. That's it. Okay, so the main thing we need to define serializer and deserializer. That is what we want to define, and also you just need to define about your schema registry. So these are the three components we are missing: serializer, deserializer, and schema registry, and these three we just configured in this YML file. Okay, but one thing I observed here, producer also need this property bootstrap hyphen server, and consumer also need this property. So better let's not define in both the place. I can define it in a global label in Kafka itself. Bootstrap server, this looks good. So Kafka having the bootstrap server for both producer and consumer, and in producer we have defined the focus on this value serializer. Okay, we have defined Kafka Avro serializer, and we are telling to the serializer about where is my schema registry up and running, so that he can add the schema to this registry. And we have the deserializer, and we are telling the again about the schema registry, and we are telling that here, okay, read the Avro messages. Fine. So we are good here. Now let me close everything. Just go to the producer. I just want to add a key. Okay, while sending the event, I also want to add a key of type. Let me zoom this for you. Of type UUID. I want to send some random string. Okay, random UUID dot toString. So while publishing the messages, I am sending the key. Along with that, I am sending the Avro messages. And if I'll open the consumer, in consumer we are consuming both key and value. Key is nothing the string, value is nothing my Avro messages, and we have defined all the component we understand in this architecture. Fine, so I believe we are good. Let's start the application and we'll see how it works. So let's go to the main class, just start the application. So we are getting some error here. What is the error? Okay, no group ID found in consumer config. So that is what the mistake we have done. We have not specified the group ID. So I'll just add group ID as a some random value. Okay, Java Techie new, all good. Let's restart it now. So we are good now. If you observe in the console, the Java Techie new is nothing my consumer group assigned to this particular topic Java Techie -Avro with the three partition 0, 1 and 2. Can you see here? Let me clear this. Now I want to verify the same thing in the control center. Okay, just go to the browser. This is where the 9021 is my control center, right? Now this is where the cluster. If I'll open this, it should have our topic info. Can you see here? The topic name is there, Java Techie Avro with the three partition. If I'll open this and if I'll check the messages, you won't find any messages because we have not published anything. So there is nothing, it's still loading, no messages, right? So let me keep a duplicate page of this particular thing, because until you are open to this page you can see only those messages. So this is just a tool to monitor the event whether it is going through your producer and consumed or not, for the simple purpose. Now if I'll check the schema here, I don't have any schema mapped to this particular topic. So here, when schema will be added, when it will be serialized, then only Kafka Avro serializer will push that particular schema to schema registry. That is what we understand in the theory, right? Let's verify it. So what I'll do, I'll go to the postman, and what is the endpoint? Let's verify in the controller class. Go to the controller events, and what is the port number? 8181, I believe. 8181, yeah. Go to the postman 8181 events, and what is the request body? We have lot of field. Let me add those field. So these are the field we have defined in our schema. Okay, so we can only pass this field, and then we'll play with the schema evaluation once we'll go through one happy scenario. Just format it. Before I send the request, let's check the status of schema registry, whether we'll verify whether schema is added to the schema registry or not. Okay, how can I validate that? So the schema registry is running on port 8081, right? First, let me 8081. I want to get all the topic name. So topic is not created here. Not sure why it's not showing in the schema registry. I believe after sending one object it will show, but okay. Let me verify the latest schema. Okay, we cannot do that since the topic is not showing here. Let me refresh it. Nothing, but topic is there, right? That's fine. Let me trigger the request. Can you see here we got the success result, message published. Now if you check in your console, send messages, this is from producer end, these are the information we are sending, and it went to the offset 0, and this is from consumer end. Can you see here? This is what the received message, and this is what the messages we send from the producer. Now to validate that, just go here. Can you see here in the messages we can see the message. This is what the messages we have sent just now, right? And if you now validate the schema, just check the schema, you can see the schema here. These are the field we have defined, right? ID, first name, last name, email with the default field, date of birth, age, and the Avro class name, package, everything. All the schema we have defined is imported here. Once the Avro serializer is serialized and send the event to the topic. Now let's verify the topic name. Yeah, can you see here the topic name is this. Now to validate the schema in the schema registry, what you can do, localhost 8081 subjects, then topic name. What is the topic name? Copy again, just replace the topic name. Can you see here? Let me zoom this for you. Subject is nothing the topic name, I mean the value as a suffix will be appended by the Kafka Confluent, and version is 1, ID is 61. This is what the schema. We can see the schema in the schema registry. So we concluded that schema registry has the schema information, while Avro serializer serialize it added to the schema registry. And since we are able to receive the messages from the consumer end, Avro deserializer deserialize it. Okay, and which version of schema we have? The current version is 1 because there is no change. This is the fresh schema added to the schema registry. So this is the happy scenario we validate, right? We can able to produce the message, and we can able to consume the message by taking the help of Kafka, Avro serializer and deserializer, and also we validate the schema in schema registry, and we can able to visualize the messages and everything from the control center. That's fine, but our intention here to check the schema evaluation related things. So if I am doing any change on my producer data, whether it will impact to my consumer or not, that is what we want to verify, and that is why we are using this schema registry. So let's jump into the presentation, and then we'll perform these schema changes. When I say schema changes, we just want to do some modification on our object which we want to produce and consume. So what we'll do, we'll remove the date of birth field and age field, and we'll rename this particular field email to email ID in our existing schema. So just go to the schema. So the schema is employee.absc. Here we want to remove the DOB and age, just remove it. And then I want to rename this email to email ID. So we have done two changes here. We have removed two field DOB and age, and we rename one of the existing field. Now let's see if I'll run the application whether it will break my consumer or my consumer will work as it is without any impact. Okay, that is what we want to verify. But since we have done the changes on the schema, we need to regenerate the object, Avro object. Let me stop the application, then just execute the Maven goal, install. So the build is succeed. Now to validate whether those fields are excluded from our Avro object generated by the Avro plugin, we can go to the DTO and we can validate. Can you see here? Those fields are not part of the Avro object now. Now let's run the application and we'll trigger the endpoint to publish the event. Then we'll validate whether the consumer is working or it is giving any error or exception. Okay, so that is the reason we are using schema registry to manage the schema if I am doing any change on my produce object or Avro object. Okay, so let's wait it to complete. So it started. Now I'll go to the postman and I'll change the field. Actually we have removed these two fields, right? DOB and age, just remove it. Age and DOB is removed, and then this will be email ID. That is what the changes we have done. Cool. Now let's trigger the API. We got the response message published. Now if we'll go to the console, you can see here, right? ID, first name, last name, and email ID. This is what the object we have produced from the producer, and this is what the serialized as part of the Kafka Avro serializer. And then if you observe here, this is what the message we have received in the consumer end, and in both the place producer and consumer we don't have those field. Now if you will go and check in the control center, if I'll go and schema, if I'll come back to the messages, so message might not be present here, so I can re-trigger it to validate that. So just send the request again. You can see the messages here, right? Those field is not part of the messages itself. Nothing is there, right? Now if I'll go and check the schema, let me refresh this. I'll come back to schema again. Can you see here? Schema is also updated. ID, first name, last name, email ID. Now if you'll check the version history, there are two versions, the initial version and second version. In initial version we have the fields, right? DOB, age and email. But in the current version those fields are not there. So if you want to compare, you can click on this turn on version difference and you can see here these are the field has been removed. So you can see the red mark here and the value is renamed. You can see this. Okay, this is what the difference. Now if you want to validate the same thing in the schema registry, instead of this control center UI, just trigger this request again. Can you see here? The version is 2 and the schema is this. This is what the latest schema. Okay, I have done the changes on the schema, but still my consumer is not breaking. I am able to consume the messages even the field has been removed from the payload or Avro messages itself. So that is the main purpose of using this schema registry. If you observe here, it maintains the schema history. Okay, so it maintains the different version of your schema. Since it has the backward compatibility, it cross validate your Avro messages with all the schema present in the schema registry. Now let's do another changes and we'll validate whether the schema evaluation is working with this particular implementation or not. So what changes? When I say changes, let's add one more field. Okay, So go to the project, go to the schema. I want to add some field. So as per the discussion, we need to add some different field like middle name or something like that. Okay, so let me add that field. First name, last name. Let me copy the same, and I want to add middle name. Now since I have done the changes on the schema, I need to rebuild the project. Let me stop the Kafka. I just need to run the Maven install again. So you can see here build is succeed. Now if I'll go to my DTO class and if I'll open it, let me see whether the field is added or not. Yeah, can you see here the middle name is added here. Now let's do one thing. Let's start the server and we'll add this middle name as part of our payload. Just check. Okay, it's still running. Let's wait it to complete. Yeah, so it is started now. Let me clear this. And now what I'll do, I will trigger the request. Okay, again we have done the schema changes. We have added the new field which is not present in my both the schema. I mean schema version 1 and 2 does not have the information about this new field. Now let's see whether it is working or we are getting any error. Then we'll try to find out the solution of it. Send the request. We are getting 500 internal server error. Now if you'll go and check in your console, the error itself self-explanatory. Invalid configuration exception. Let me zoom this for you. Schema being registered is incompatible with an earlier schema, error code 409. It means whatever the schema I have with me and the value you are giving now is not compatible. Then how can I make my schema as a compatible to avoid this 409 error? So what you can do, if you are adding any new field, then initially mark it as a default. Okay, then what you can do, since you have done the changes, just build it again. Then we'll start the server and validate. So build is succeed. Now let me restart the server. So it started. Now go to the postman and send the request again. The message has been published. Now if you'll go and check in the messages, can you see the message here with the new field middle name? Can you see here? We got the response. Now if we'll validate the schema again, version history, there are total 3 versions. In first version it was the happy scenario, we have all the field. In second version we have removed the DOB and age and we rename email ID. Then let's see what is there in the third version. Third version we have just added this field middle name. Now if you will compare it, you can see this field is newly added. Okay, and we are not getting any error. So this is how schema registry maintains the schema and validate against the Avro messages what you are producing and what you are deserializing or consuming. And this way you can avoid the failure in the schema evolution which will not break your entire system. Okay, so this is what the straightforward approach we have demonstrated about the schema evolution using schema registry and Avro producer and consumer example. Okay, do let me know in a comment section if you guys have any doubts. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.